Okay, now we are ready to solve the third question. Alright, so if you're new to my channel, you're welcome to Sumptuous Teachers channel on YouTube. Okay, so in this video, this is actually the third one. You can see the first question we've solved for that. We are done with the second question, and now we are about to do the third question. Alright, okay, so it will be necessary for you to go back and look at this first two because they are a little bit simple compared to this one. In fact, this one is more simple, but this will help you, okay, especially the first one. Alright, so you go back there and look at them. Okay, let's just continue solving. Now this number 3, we will have that 2 times this and then this to power this. The power is a little bit complex. In fact, it is nothing. We can deal with it, alright? We subtract 3 from that and it is equal to 0. So solve for the value of x such that this equation is satisfied. Great. The first thing I would like to start with is this exponent, alright? I'm going to work with this. I'm going to rewrite it in a simple form so that we can actually make use of it. Now, this is what we will do. When we have this kind of fraction, we have 2 to the power of x, sorry, not 2 to the power of x, 2 times x, alright? 2 times x plus 1 divided by 2. Here, you can simply split the fractions, alright? So you will be having 2 times x over 2 plus 1 over 2. Okay, that is how to split the fractions. So when you have a denominator, whether it is a sum of some terms or it is a product, all you need to do is to keep that denominator. Keep it, don't split it. Only split the numerators. Split the numerators is possible when you are having addition in the numerator or subtraction. You can split them, alright? In this manner, keep the denominator. What I mean is, if you have x plus y divided by z plus t, okay, the only way you can split this is to take x over z plus t, then plus y over z plus t, alright? You don't split the denominators, you only split the numerators. Alright, great. Now here we see that 2 and 2 will cancel, and we're just having x plus 1 over 2, alright? And remember, we were having 3 raised to the power of that. That means this can also be taken as 3 raised to the power of that, because this has been reduced to this form, alright? And from what we've learned already, we will know that this is the same thing as 3 to the power of x times 3 to the power of 1 over 2. Okay, so since we are adding the powers, we can rewrite it as this. The product, the same basis with the powers, where we have to add these powers backwardly. Okay, so 3 to the power of 1 over 2, in fact, is the same thing as square root of 3. So I would like to write this down as square root of 3. So this is the same thing, finally, as the square root of 3 times 3 to the power of x in place of this. Alright? Very nice. So in place of that, I'll write minus the square root of 3 times 3 to the power of x, like that. Okay. So we just put this other one down, but I'm going to rewrite this as 3 to power 2. You know that is 9. 9 is the same thing as 3 to power 2. So we'll put this down as 2 times 3 to power 2. 3 to power 2 raised to power x. That will be 3 to power 2 times x. Alright? Okay, so this is 3 to power 2. That is only 9 is 3 to power 2. We raise it to x. Alright? Since 9 was being raised to power x, 3 to power 2 is just 9. You raise it to power x. So here we can interchange this and rewrite it as 3 to the power of x and raise it to power 2. They are the same thing, because here all we need to do is just to multiply the powers. And by multiplication, it is commutative. The order does not matter. We can put this one first. Okay, so this is it. 3 to the power of x, all raised to power 2, like that, alright? Okay, so we subtract this other 3, we equate this to 0, and we are good. Next thing, well, we actually have to solve this. You know, I've reduced it to a quadratic equation, right? Maybe I need to make it obvious. What we need to do is to make a change of variable. Okay, we need to make 3 to the power x to be something. I like using t. So I'll say let 3 to the power of x be equal to t. Okay, so in place of 3 to the power of x, we just put t. This is what you will have. We are going to have 2 times, right, t squared, that is 2 times t squared, minus the square root of 3 times t, right, minus 3 equals to 0. So in place of 3 to the power of x, we just put t. Okay, this minus that. Okay, great. Now here we are going to use the quadratic formula to solve this quadratic equation. Okay, so what we do is to just say that t, the values of t, right, let's put it down, will be, by recalling the formula, we have negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so this is the a, this is b, negative root 3 is b, and negative 3 is c. Okay, so you take note of that. So in the formula, we have negative b. Okay, that will become negative b. B alone is negative root 3. So negative of negative root 3, that will be positive root 3, right? Plus or minus the square root of b squared. So we have negative root 3 squared, that is b squared. In fact, negative squared, that will become positive. Root 3 squared, that will become 3, right? Because this square kind of cancel there. Square root, right? Because this number is a positive number. So that will cancel and we just left with 3. Negative b, okay, b squared minus 4 times a. So 4 times a here is 2. Times c here is negative 3. So you take note of that, right? Divided by 2a. So 2 times a is 2. Alright? Okay, great. We can simplify this further. We have square root of 3 plus or minus the square root of. Now, we have here to be 4 times 2. Okay, that is 8. 8 times negative 3. Okay, let me put this negative side to not confuse us. Negative 4 times 2, that will be negative 8. Then negative 8 times negative 3, that is positive 24. Alright? Okay, this is 3 plus 24. The denominator, we just have the 4. Alright, so this alone, 8 times 3 is 24. Okay, so 24 plus 3 now is now going to give us 27. Alright, square root of 27 over 4. Okay, so maybe I would just like to split this. Alright, here we can rewrite this as, now let me show you something. When we have square root of 27, this is the same thing as 3 root 3, right? Okay, 27 is the same thing as square root of 9 times 3. That is 9 times 3 will give us 27, right? We can split this as square root of 9 times the square root of 3. Okay, so when you have square root of product of numbers like this, it is possible, because this is a product, to split them. So you take the square root of first times the square root of the second. If it was addition, you don't try this, alright? So the square root of 9 is 3. Times the square root of 3 can't be reduced further. It's an irrational number at that state. So you just put this down. 3 root 3, alright? So it means that this square root of 27, like we just finished, is the same thing as 3 root 3. So in this place I would like to write 3 root 3. Okay, so we see that root 3 is common in the bracket, is common. We can actually factor it. We're going to have square root of 3, okay? Here we're going to have 1 plus or minus 3 over 4. Is that clear? When we factor the root 3, we are going to have 1 here plus or minus 3. Maybe let's just split it first. Here we are going to have t1, 2. In fact, let's just say that t will be square root of 3 plus 3 root 3 divided by 4, or square root of 3 minus 3 root 3 divided by 4. Okay, so split it into 2, the plus and the minus case. Root 3 plus 3 root 3, that is 4 root 3, right? X plus 3x, 4x. Root 3 plus 3 root 3, that is 4 root 3 divided by 4. that is for the t, okay, or the second one is, this is root 3 minus 3 root 3. If you have x minus 3x, this is negative 2x. So root 3 minus 3 root 3 is going to be negative 2 root 3, right? Negative 2 root 3. So in place of root 3, just put x so that it will be clear to you, right? So you don't get confused, actually. So here we'll be having negative 2 root 3 divided by 4. Maybe we can go ahead and simplify this further in some other space. Okay, so we will enter with t is, here we just have root 3, okay, or, now, when we divide this with that, we are going to have negative root 3 over 2, right? So negative 3 over 2. Okay, great. Now, t is equals to root 3 or t equals to negative root 3 over 2. We would like to make a backward substitution. Initially, we said that 3 to the power x should be t. So that means that in place of t, I would like to put 3 to the power of x. So that means in place of t here, we just put this down, 3 to the power of x. Alright? On the left-hand side. Now, square root of 3 is the same thing as 3 to the power of 1 over 2. Okay, so what you would like to see here is that these bases are the same, so we will cancel them and just take the powers. So by equating the powers, we see that x is 1 over 2. Now, we would also like to do the same thing to this guy. We will have 3 to the power of x in place of t, alright, a backward substitution, and we'll have negative square root of 3 over 2. Now, when you have an exponential function, 3 to some power x, where x is the unknown, and you're having negative as a result, this is not possible in the set of real numbers. You can't raise a number to some power, even though the power here is negative, it does not matter. You cannot have a negative result. So this one is impossible, okay, in the set of real numbers. So the only real value for x is 1 over 2. Okay, that was very nice and wonderful. Alright, thanks for watching and please subscribe to my channel.